let's move on. Let's look at another operation on polynomials, multiplying. All right, this one's going to be a little bit new, but we mixed with a little bit of the beginning of chapter 5.4. I'm going to say this also incorporates 5.5. This is kind of like a 2-in-1 section. So we'll cover all the multiplying that we can do. Right? We already know how to multiply monomials together. So remember, that's just a single term times a single term. This is nothing new. All right, this is a single term multiplied by a single term. Right? We know what we get. We multiply coefficients, right, and we add the exponents. So, right, nothing crazy there. Exactly what we remember should happen happens. All right, so how is this going to change when I want to multiply polynomials together? Honestly, not much. And let's look at a situation that's similar. Here we have a single term, a monomial, and we're multiplying it by a polynomial, 3 terms. Exactly what you think should happen does. If I want to get rid of these parentheses, I need to distribute. So we're creating 3 separate multiplication problems, and all of them abide by our property 1 of exponents. When I multiply, I add exponents. Okay. I still multiply coefficients though. So 3x times 4x squared, sure, that's going to be 12. Add our exponents, x to the 3rd. Okay. 3x times 2x. Right, 3 times 2 is 6, and x times x. Add the exponents, and we get x squared. 3x times 1, well, that's not too bad. Anything times 1 is itself. It's going to be 3x, and we're done. Right, so multiplying a monomial times a polynomial isn't anything special. We're just creating 3 of these smaller problems. So I'll do one more example of this, but there's nothing new really. If I had, say, 5a squared b times 2a third b to the 3rd minus 4a squared plus 3b. Looks more complicated. Sure, there's more variables in it, but right, not really more difficult or adding anything to the puzzle here. We need to take this one single monomial, distribute it to the 3 terms in this expression, right, and really just play this single game 3 times. This times this, 5 times 2, 10. Right, add our exponents, a squared and a to the 3rd, a to the 5th. B and b to the 3rd, b to the 4th. All right, next game. 5 times negative 4 is negative 20. A squared and a squared should add up to a to the 4th. And b, there's no b's here, but this b is still getting carried along. I'm still multiplying by b, so it's still part of that term. Last problem. 5 times 3 is 15. Again, I have this a squared, it's along for the ride, it's still in this term. And then we have b times b, should be b squared. All right, and we're done. All right, so we can multiply a single term times however many terms I want just by distributing. Okay, so whether there's more terms or less terms shouldn't really be a problem. Okay. All right, so let's see what happens when we change that a little bit. Instead of a monomial, all right, let's take a polynomial times another polynomial. So 3x plus 1 times 2x plus 5. Now we have a binomial, 2 terms here, times a binomial, 2 terms here. All right, we multiply. If you've seen this before or done it, you might be familiar with the phrase foiling. Right? I'm probably going to use that term a lot. Sometimes I categorize it as something else, but FOIL is a good term just to describe this type specifically of multiplication, a 2 by a 2. It's an acronym that stands for first, outside, inside, and last. Right, it's a way to remember which pieces to multiply together, but it's not like you need a little saying to remind you what needs to be multiplied together. You know how to distribute. And if I said, I want to take this 3x, if it was the only thing that was out here, you'd say, oh, I know what to do with that. Just like over here when it was one term. I distribute that single term. Right? And similarly, if I just had a 1 here, I mean, that would be a little boring, but there's 1, you'd say, oh, I know how to handle that. I'm going to distribute it to both of the terms over here. So all we're doing is kind of a double distribution process. Every single term in this polynomial is going to be multiplied or distributed into every term in the second polynomial. And that's where this comes from. When I take this first piece, this 3x, and I multiply it by this first piece, first times first, 3x times 2x will get us 6x squared. Remember the squared, add the exponents. All right, the outside two pieces would, again, just follow this natural distribution process. I'm distributing 3x times 5. These are the outside pieces. That'd be a positive 15x. The 3x is done. Now let's move on to the 1 and distribute the 1. 1 times 2x. That'd just be a positive 2x. All right, those are the two inside pieces. And then the last two pieces, the last of this polynomial, last of this, 1 times 5 would be a positive 5. Make sure you put the correct signs in between each. And now we want to keep simplifying. Right, when we do this FOIL process, we'll generally have two like terms in the middle, 6x squared. Right? And remember, when you're adding, you're looking for like terms, and when you find them, you just add the coefficients. You're not changing the exponent again. This is just 15 plus 2. I have 17 x's plus 5, and I'm done. All right, so this process, a little bit different, a little bit more involved, but again, we're just multiplying. It's a lot of these steps over and over again. There's nothing really revolutionary here. Just takes some practice getting used to all the multiplying and remembering to simplify in the end. Let's look at a different example. 2x minus 3y times 5x plus 4y. Binomial times binomial. Right, this is going to be a very common theme. It's going to pop up in almost every section in chapter 6 where we're dealing with these binomials. So we should get used to it. And this FOIL process should just fall out. And we're going to get very good at this. All right, distribute the 2x. 2x times 5x would be 10. Add the exponents x squared. 2x times 4y, both positive, so we end up with a positive 8x and a y. Go for the insides, distribute the negative 3y, so make sure you're accounting for this negative. Negative 3 times positive 5 would be negative 15. We have an x and a y. Right, it doesn't really matter what order you put x, y. It's just really common to write it in alphabetical order, so it's easier to see these are like terms. And then negative 3y times positive 4y would be negative 12y squared. Right, again, despite the more variables involved, these two middle terms are alike, so 10x squared. 8 minus 15 would be negative 7xy minus 12y squared. All right, so there's our FOIL process. All right, there's nothing really fancy with it, just takes some practice, some getting used to. Our next video will explore a little different ways to do this FOIL process, but in the end, it's unavoidable. We're really just taking this term and distributing it, taking this term and distributing it, seeing what that gets us. So, see you in the next video.